Welcome to this lesson video on asphalt production. In this lesson, we'll learn about asphalt material, the different specifications used for its main mixing ingredients, the asphalt mixing plants, and their safety precautions. Asphalt is a very fundamental building material that can exist naturally or artificially. The Trinidad Lake is the most famous natural asphalt source. Nowadays, asphalt is produced as a byproduct of crude oil distillation and refinement. Around 1 to 2% of crude oil is refined into asphalt. Asphalt is a major element in constructing flexible pavements. This pavement type gained its name from the viscosity and flexibility of asphalt as its binding material, compared to rigid pavements made from plain cement concrete (PCC). The pavements are designed with the objectives of supporting the traffic load, mainly truck axle loads, protecting the aggregate subbase and base from moisture and rain runoff, providing good riding quality, and minimizing the pavement costs over its life cycle. Asphalt is used in two main products that are used in constructing flexible pavement: asphalt concrete and liquid asphalt cement. Asphalt concrete is made of asphalt cement and aggregate. The amount of aggregate and asphalt mixture is generally 90 to 95% by weight and 75 to 85% by volume. This large aggregate proportion is due to the fact that the axle load on an asphalt pavement is primarily carried by the aggregates in the mix. The mix of the asphalt concrete is designed using different standard specifications like HV and Super Pave, and the mix is produced in asphalt plants similar to the ready-mix concrete plants. The asphalt concrete is used to construct the asphalt surface courses in the pavements, namely the wearing course and the binder course. This photo here shows the different look of the binder and wearing courses, and you can see that the aggregate size difference between them. There are 5 main considerations when selecting aggregate in an asphalt concrete mix. Let's briefly cover each of them. Well-graded aggregate is a requirement for strong asphalt concrete. Super Pave specifications define the required gradation of each standard mixes using its own value of nominal maximum aggregate size and mass and corresponding control points. N mass is one size larger than the first sieve that retains more than 10% of the aggregates. N mass design values in Super Pave are 37.5, 25, 19.5, 12.5, 9.5, or 4.75 millimeters. In asphalt plants, the aggregate gradation requirement is achieved by mixing aggregates from 3 to 5 segregated stockpiles that follow a coarse, medium, and fine classification of the aggregates. The aggregate proportions from these stockpiles are determined to create a job mix formula that's followed during the asphalt mixing. Texture is a very important aggregate factor, especially in asphalt concrete, as it determines the level of interlocking between the aggregate particles, which in turn defines the mix strength. Round river run aggregates are not recommended for asphalt mixes, but they can be crushed to create angular aggregates that can be used in asphalt mixes, following specific requirements about the minimum number of crushed grain faces and their percentages in the aggregate. Clean aggregates are critical to have durable asphalt mix, and this is why it is important to limit the amount of any foreign material that's not specified in the mix design, like clay, dust, and organic material. The porosity level of the aggregates is an important factor in designing the mix, as it can increase or decrease the asphalt cement in the mix to account for the binder amount that's absorbed by the aggregate. Finally, the bonding between the aggregate and asphalt cement binder is important, and some aggregate types can have binding compatibility issues with some asphalt cements. To resolve this bonding problem, anti-strip additives are added to the mix at the production plant or in the supplied asphalt cement. Let's now switch gears to the second component of the asphalt concrete, the asphalt itself. Traditionally, asphalt has been hot mixed in high temperatures to achieve specific viscosity levels to allow the binder to coat well the aggregate. There are also warm mix asphalts, which are heated at lower temperatures but using additives that work as mixing lubricants and lower the required mixing temperature. Standard asphalt mixes are specified using three main approaches: penetration grades, viscosity, and performance grades. An asphalt mix is given a penetration grade based on an ASTM grade, standard test that measures its Hen value as the distance in 0.1 millimeter that a 100 gram needle penetrates into an asphalt mix, cement mix within 5 seconds at a specific temperature. The mixes can follow the shown 5 standard pin grades. The higher the pin value, the more viscous the mix will be. Viscosity is a better property than penetration to engineer and design a building material. There are two viscosity grading types, AC and AR. With AC grading, the asphalt binder is characterized by the properties it possesses before it undergoes the HMA manufacturing process, hot mix asphalt manufacturing process. The AR grading system is an attempt to simulate asphalt binder is 1 minute. The AR grading system is an attempt to simulate asphalt binder properties after it undergoes a typical HMA manufacturing process, and thus it should be more representative of how asphalt binder behaves in HMA pavements. Viscosity is measured in poise, where a low viscosity asphalt mix will have a low poise value. The shown table lists the different viscosity standard AC and AR grades, which communicate the poise required values for the different mixes. For example, AC 5 mix is more viscous than AC 40 mix. The most common used asphalt mix grades are AC 10, 20, 30, and AR 40 and AR 80. The third grading system is based on the asphalt mix performance, considering different quality metrics like penetration and viscosity. The performance grading is designed following high and low temperature schemes. The shown figure shows the different performance grades that are created by matching the different high and low temperature values that are segregated using fixed 6 degrees Celsius intervals. A high-performing grade mix is the one that can perform well at both high and low temperatures, like grade 7640. In addition to temperature, the asphalt performance grade is selected considering the traffic speed and truck traffic volume. A low traffic speed and high traffic volumes require upgrading the performance grade to increase the pavement durability. We covered so far the asphalt concrete mix that's used to construct the pavement wearing and binder courses. Liquid asphalt cement is applied between the different layers of the pavement to maintain adhesion and waterproofing between the layers. The liquid asphalt state is maintained during the material application on the construction site using additives that allow heating the mix to temperatures much below the temperature applied in asphalt concrete mixing. Based on the applied additives, there are two types of asphalt cement liquid. First, asphalt cutbacks are made by adding a fuel product like gasoline and diesel to the asphalt mix, which is clearly not that environmental friendly. These days, asphalt emulsions have been used instead of fuel products to lubricate the mix. Emulsified asphalts are made by adding water and emulsifying agent to the asphalt cement. The agent is a soap-like material that keeps the asphalt cement particles suspended in the water. The liquid asphalt is applied in two coats that exist at different locations within the pavement section. The prime coat is sprayed on the aggregate base before laying the asphalt binder course, while the tack coat is applied between the asphalt course and wearing courses. There are two types of asphalt concrete mix production plants. Let's check the first type, the batch plant. Asphalt batch plants are considered the traditional designs of mixing plants, where the mix is done in batches of set proportions that are produced through the plant. Let's see the components of a typical batch plant. The cold feed bins hold the different coarse, medium, and fine aggregates that are ready to be mixed according to the mix design. A belt conveyor runs under the bins to collect the aggregate from the different bins from below and delivers them to the drum dryer. Inside the drum dryer, the aggregates are tumbled through a stream of hot air. The drum has steel angles to move and mix well the aggregate. The hot aggregate is carried by the conveyor to the top of the batch plant tower, while the exhaust air goes through the dust collector. The drum dryer helps to remove any moisture in the aggregates, clean them from dust, and heat them before they get mixed with the asphalt cement. The right temperature should be achieved here, as low aggregate temperature will prevent the aggregate cement bonding, and high temperature will harden the cement during the mixing process. The dust collector, or the baghouse, filters the exhaust air from the drum dryer before releasing it to the outside air or recycling it back to the drum. In filtration mode, the dust air flows through the filter bag walls, leaving the dust particles hanging on the bag from outside. In the bag cleaning mode, the air flow is reversed to kick the collected dust off the bag. The asphalt cement or binder is stored in a hot liquid storage tanks that keep the asphalt in the required temperature. The tank temperature is maintained using direct fire heater that changes the temperature for every unique asphalt grade. Typically, the storage temperature is kept to 275 degrees Fahrenheit for soft asphalts like PG Performance Grade 5234 and 330 degrees Fahrenheit for hard asphalts, like PG 7022. The last and most visible part of the batch plant is its mixing tower, which houses hot aggregate elevator, hot screens, hot bins, aggregate weight hopper, asphalt weight bucket, and hog mill or mixer. The elevator delivers the aggregate to the hot screens, which split it into 4 hot bins. The mix ingredients are controlled using the weight hopper and buckets, and then dumped into the bug mill for mixing. The delivery trucks drive under the tower to load the asphalt mix and deliver it to the site. Let's now see how drum mix plants are different. They are similar to the batch plants, but we see there's something missing. Yes, it's the mixing tower. The sieving, weighing, and mixing functionalities of the tower are now done by the drum and the cold feed system. In the cold feed system, the aggregate is weighed and sieved per the mix design requirement, considering the moisture content already existing in the bins. The drum here performs both drying and mixing. Let's summarize our asphalt production plant's discussion with a comparison table. As we discussed, the drum and cold field system in the drum mix plant replaced the weighing and mixing functionalities of the tower in the batch plant. Batch plants are more flexible to change the mix design, as the mix customization is pushed down the plant all the way to the mixing tower, while we need to wait for the drum mix plant to be done with its mixing in the drum to start a new mix from the cold feed system. On the other hand, drum mix plants are newer with more efficient heating and mechanical systems, which make drum mix plants more economical. Last topic to cover is in this lesson is for safety considerations in asphalt production. You can guess by now that there are mainly 2 safety hazards in asphalt plants: fire and moving mechanical parts. There are serious fire hazards in these plants due to the continuous heating of the liquid asphalt and the mix at high temperatures. Also, plant operators are under the risk of being entangled in the belts and conveyors that can suddenly start running for an asphalt concrete mix. Thank you for watching, and take care.